You know what's really scary? It's not ghosts, blood, or clowns. It's knowing that there could be a planet lurking in our solar system. Maybe twice the size of Earth, and we have no idea it's there. Can't see it because it's hiding beyond Neptune. That's why they call it Planet 9. It's not official yet, but if confirmed, this planet will be the first to be discovered since Neptune 170 years ago. But are we ready for it? Hi, it's me, and this is my channel. So here's the real talk on Planet 9. You may have heard about it back in 2016, when astronomers made headlines claiming that they'd found evidence of a mysterious planet whose orbit was 6 times further out than Neptune's and whose mass was around 10 times larger than Earth's. This hypothetical planet would be so massive that its gravity would affect the path of small objects in the Kuiper Belt, the region of our solar system beyond Neptune. But then other scientists were like, hold up, because these claims were based on computer simulations. Nobody had actually seen this planet, so over the last 6 years, various research teams have been hunting for Planet 9 by scouring the night sky with telescopes and searching for shadows cast by exoplanets passing between us and distant stars. But even though we still haven't spotted it, there's reason to believe that there could be something out there. After all, we don't have any good explanations for the clustering of orbits that has been observed among some Kuiper Belt objects. In 2021, one team of researchers came up with an alternative hypothesis. Instead of challenging the existence of Planet 9, they suggested that the strange orbital clustering might just be an observational bias. In other words, we think these paths are weirdly grouped together simply because we aren't looking far enough. The problem is, it's hard to study the Kuiper Belt because objects out there are just so dim. They're really far away and pretty small compared to the sun. The only way we spot them at all is by shining a telescope on a star and seeing how its light gets blocked by a passing Kuiper Belt object, a method called transit photometry. And while this technique works well for finding exoplanets orbiting other stars, the farther away the object is from the sun, the harder it is to find. That's why the team behind the 2021 paper said that rather than searching near Neptune, the focus should be on surveying further out in the Kuiper Belt. And thankfully, new telescopes like the Vera Rubin Observatory in Chile, which began operations this year, are perfectly equipped for this kind of survey. One of the observatory's main goals is to map out the population of the Kuiper Belt in greater detail. But here's where things get even more complicated. Not everyone agrees that we need to be looking out there. A different team of astronomers recently argued that instead of searching in the Kuiper Belt, we should be focusing our efforts closer to home, specifically within the orbit of Jupiter. This proposal was based on a statistical analysis of minor planets, also called asteroids, that orbit the Sun, like Kuiper Belt objects. Asteroids are too small to have cleared their orbit of other objects. And thanks to modern telescopes, we've cataloged most of the ones that pass between Mars and Jupiter. But there are some gaps in our records, specifically around the orbit of Jupiter. One explanation for this is that many of these asteroids have been destroyed by Jupiter's powerful gravity. And if true, this suggests that there could be a lot more asteroids that we haven't seen, which means we may have missed a planet-sized object that's much closer to home than Neptune. It's estimated that such an object would have to be around 5 times larger than Earth. But again, nobody has actually seen it. What complicates matters further is that it isn't clear whether Planet 9, if it exists, is formed naturally in our solar system, or if it's a space rock that got captured by the sun's gravity. If it did form out there, that would suggest that the conditions in our early solar system were very different than they are now. For example, there must have been a giant protoplanetary disk around the sun and enough mass in the outer solar system to form more planets like Neptune. Alternatively, if Planet 9 was captured later, that could hint at the existence of another star that kicked it out of its original solar system. So as you can tell, it's not as simple as saying, hey, we found a planet. There are a lot of details to consider, which is why observations from telescopes like the Vera Rubin Observatory are so important. Once we have more data, we can better understand the distribution of objects in our solar system and rule out some of these hypotheses. We can also try to measure the mass of certain objects by watching how fast they move. You see, the gravitational pull of Planet 9 or any other large object would speed up smaller Kuiper Belt objects as they pass by. So if we observe a group of objects traveling together, we could estimate the mass of the unseen planet by measuring how quickly they're accelerating. In fact, the team that originally claimed to have discovered Planet 9 used a similar method. They studied a cluster of asteroids that had unusually high speeds, which they attributed to the gravitational influence of a hidden planet. But if we do find Planet 9, it won't necessarily look like Earth. It could be covered in ice, or have a thick atmosphere, or even be made of rock. It could also be tidally locked to the sun, meaning that one side always faces us, and the other side always faces away. That means that even if it's twice the size of Earth, it could appear no bigger than a star in the night sky. And that's why searching for Planet 9 is like searching for a needle in a haystack. There's a lot of sky to cover, and it's hard to tell what might be hiding in the darkness. But that's also what makes the search so exciting. We don't know what we'll find, if anything. But either way, the hunt is on, and there's a lot more data coming our way. In the meantime, we can keep looking up and dreaming about what it would be like to know that there's a planet out there that we haven't even seen yet. As Carl Sagan once said, somewhere in the darkness, the planet is watching us watching it. Thanks for watching this episode. You want to help support the channel? We have a platform where you can support things like this. You can check out the platform if you want to learn more. All the stuff we learn in school is just the tip of the iceberg. There's so much more to know about our solar system and the universe, but it can be hard to dig deeper when you don't have a degree in astrophysics. That's why I started this channel and why so many other educational creators out there do what they do. We want to share our passion for learning with others and show people that knowledge is power. And the best part is that anyone can be a lifelong learner. All it takes is curiosity and a willingness to explore the unknown. We want to make it easier for people to access great educational content like this, not just on our channel, but on other platforms too. And that's why I'm so excited to introduce our new membership program. Our channel is supported by a community of learners, all united by a love of knowledge and a desire to make the world a better place. When you join our platform, you're joining that community. You'll get access to exclusive perks like early access to videos, fun polls, and chats with other learners and creators, and even live streams. And if that's not enough, you'll also get access to a vast library of incredible nonfiction books. You can read best-selling memoirs, learn how to make the perfect mac and cheese from scratch, or dive into the science behind one of your favorite sci-fi movies. With so much to choose from, you're sure to find something that sparks your interest. Plus, it's a win-win. When you sign up for Nebula, you're not just getting a great deal for yourself, you're also helping us create even more amazing content for everyone. So if you're ready to join the movement and become a lifelong learner, click the button on screen. It's just $2.99 a month. Thank you for watching and learning with us.